The next thing we'll look at factoring is factoring trinomials. And we'll start with the simpler case. Things of the form x squared plus bx plus c. And we want to be able to write this as x plus p times x plus q. And we have two properties that we're going to need. We need p plus q to be equal to b, the coefficient of x. And we also need p times q to be equal to c, my constant term. And one of the easiest ways to do this is to find everything that multiplies to give our value of c, and then see which one of those also adds to give us the value of b. So let's look at a few examples. X squared plus 8x plus 12. I want to find things that multiply to be 12 and add to be 8. Well, I know 1 times 12. I also know 2 times 6, or 3 times 4. This gives me 13, 8, and 7. So I have my 8. That would give me that this factors into x plus 2, x plus 6. Next, let's look at this x squared minus 7x plus 12. So once again, I need all the things that multiply to be 12. 1 and 12, 2 and 6, and 3 and 4. And once again, that adds to be 13, 8, and 7. However, I actually need them to add to be negative 7. But another thing that multiplies to be 12 is actually negative 3 times negative 4. And negative 3 plus negative 4 is the appropriate negative 7 that we need. So if my middle term is negative, then we're going to have to negate the terms. Now let's look at x squared minus 7x minus 18. For this one, I need two numbers that multiply to be negative 18, and this is going to be quite a long list. I have negative 1 and 18, as well as 1 and negative 18. Those add to be 17 and minus 17. I have negative 2 times 9, as well as 2 times negative 9. Those add to be 7 and negative 7. I also have negative 3 and 6, as well as 3 and negative 6, which both add to be 3 and negative 3. So here's the negative 7 that I need. That tells me I need a positive 2 and a negative 9. Now that we're a little more comfortable with those, let's expand it to have a number in front of the x squared. X squared plus bx plus c. And there are a couple of different ways to factor these, but I'm going to do what's called the AC method. So step 1 is to multiply my a and my c, hence the name AC method. We then need to see what multiplies to be AC, so I need to find my numbers PQ such that P times Q is equal to AC, and P plus Q is equal to B. So very similar to what I've been doing. 3, I need to rewrite my polynomial, which I'll go into that in a little more detail when I do the examples, and then factor. So let's look at a few examples. Our first example, 3x squared plus 17x plus 10. So we need to multiply a times c, so 3 times 10 is 30. And then need to list all the numbers that multiply to be 30. That's 1 and 30, 2 and 15, 3 and 10, and then 5 and 6. Adding them, I get 31, 17, 13, and 11. Since I need the 17, I have 2 and 15. So those are my first two steps. Rewriting the polynomial essentially rewrites the middle term, this 17, as 2 plus 15. So I'm going to write it as 2x plus 15x plus 10. And then we factor by grouping. These first two terms have an x in common. I'm left with 3x plus 2. These next two have a 5 in common, and I'm still left with 3x plus 2. Now I can see that they both have the 3x plus 2 in common, and I'm left with x plus 5. Another one, 4x squared minus 13x plus 10. So this time, 4 times 10 is 40. So I need to find all the things that multiply to be 40. I have 1 and 40, which adds to be 41. 2 and 20, which gives me 22. 4 and 10, which gives me 14. 5 and 8, which gives me 13, which is exactly what I need. So now I'm going to rewrite this. 4x squared minus, since we have the minus 13, we're actually going to do minus 5x minus 8x plus 10. These first two terms have an x in common. I'm left with 4x minus 5. The next two have a negative 2 in common. And I'm left with 4x minus 5. So now they both have the 4x minus 5. And I'm left with x minus 2. My next one, 6x squared plus x minus 12. So 6 times negative 12 is negative 72. And there are obviously a lot of things that add to be, or multiply to be negative 72. Since we need them to add to be 1, we can probably guess that they're really close to each other. So looking at this, I could figure out that 72 is 6 times 12, but what else? Well, it's also 8 times 9. So I could do negative 8 times 9 to get 1. I could also do negative 9 and positive 8 to get negative 1. However, I need this to be a positive 1, so 6x squared minus 8x plus 9x minus 12. These first two have a 2x in common, and I'm left with 3x minus 4. The next two have a 3 in common, and I'm left with 3x minus 4. Now they both have the 3x minus 4 in common. I'm left with a 2x plus 3.